Prompts aren't just a one-off that you give to the large language model. You shouldn't just think of them as questions or a single statement. One of the most powerful ways of working with a large language model is to think about a prompt as a conversation. And in fact, you can have a single prompt that represents an entire conversation. And in fact, a lot of what we're going to see when we're working with a tool like ChatGPT is that it's actually turning all of our interactions into one big prompt that it's sending to the large language model. But I want to just take back for a second and sort of take us back a few steps and think about why thinking of having a conversation with a large language model is so important, as opposed to thinking about asking a question and getting an answer, or giving an instruction and getting a result. Conversations are all about refining either our understanding, to build some shared understanding, or to interact together in order to solve a problem. When we start working with conversations, it's all about refinement, of continually sort of guiding and moving through some problem or some space in order to reach a particular goal. And when we just think of a one-off, we have to solve everything right now, right in this moment. We have to design one prompt that works and everything is right. But if we think about a conversation, we can go through sort of an iterative refinement process. Now, what does that mean, iterative refinement? Well, if we think about a large language model like ChatGPT as a tool, you can imagine Michelangelo has been given a new hammer, and he's going to go up to a piece of stone and he's going to start carving that stone into some beautiful sculpture like the Pietà, the David, or whatever the sculpture is that he's going to create. And he walks up with that hammer and he whacks the sculpture with this hammer, and a piece falls off, and he whacks the stone with the hammer and a piece falls off, and he looks at what he's got and he said, "Oh, this is a terrible sculpture," and he throws the hammer down on the ground and he says, "It didn't do a good job," and he walks off. No, that's not what happens. What does Michelangelo do? He takes the hammer and he hits the rock over and over, refining and shaping and sculpting it over time. He refines, he iteratively refines that rock until it's a beautiful sculpture. And a lot of what we need to do with large language models is think in that mindset of, it's not about getting the perfect answer right now from this prompt. It's about going through an entire conversation with the large language model that may be involving a series of prompts and the outputs from a series of prompts. And we'll talk about how these things are represented later. But basically having a conversation with a large language model in order to produce an output that we want, or to produce some other interesting product. Now, I'm going to give you an example of this. I'm going to imagine and show you the power of a conversation in the context of an educational experience. So I'm going to say to ChatGPT, I want you to help me explore a virtual lab for building robots. The lab is a university. Help introduce me to the lab and tell me what I can do here. So this is a virtual lab in a university. And all I've done is given it this sort of initial seed of the conversation. And ChatGPT says, certainly, welcome to the virtual lab for building robots at our university. The lab provides an immersive, hands-on learning experience. And it goes on and it tells me, here are some of the things you can do in this lab. Design robots, test robots, program robots, collaborate with others. So I then say, I'm going to continue the conversation. But I'm going to continue the conversation just assuming that this lab exists and that I can interact with it. And so I say, can we design a robot together? And ChatGPT says, absolutely, I would love to collaborate with you on designing a robot. To get started, we can follow these general steps: define the purpose and function, brainstorm design concepts, determine the necessary components, build and test, and it goes on to tell me a number of steps. So then I follow up in the conversation with, great, can you guide me through each of these steps one at a time? At the end, I would like to be able to 3D print parts to assemble my robot, have a circuit diagram, and have code that I can run to control the robot. Can you help me with that? And so this is an interesting aspect. I'm having a conversation, but I'm also engaging the large language model. I'm engaging it to help guide the conversation and help figure out how to solve the problem that I'm interested in. And so it says, sure, I'd be happy to guide you through each step of the process. Here's a detailed breakdown of the steps that we can take to design and build a robot together. Step 1, define the purpose and function. 2, brainstorm concepts. determine the necessary components, and it goes on to tell me a bunch of things. So I say, okay, let's do step one. So I'm continuing the conversation. I want one of those robots that can follow a line on the floor. And I've seen these things. These are common at universities. They'll build them. You put it on the floor, and the robot will follow some line, like a piece of tape that's on the floor or something that's painted. And it says, great, following a line on the floor is a common task for robots, and there are many ways to approach this problem. Here are some questions to consider as we define the purpose and function of our line-following robot. What will be the primary use? How fast do we want the robot to follow the line? How complex do we want the following to be? What sensors do we want to use? And I just tell it, hey, I'm not really sure. Could you make some sensible choices for me in all of these things? And ChatGPT says, sure. Based on my experience, I can make some suggestions, and it gives it its purpose and function. It's going to be for educational purposes, speed and distance, moderate speed that is easy to track, such as 10 to 15 centimeters a second. Complexity, we'll design it to navigate through a simple track with straight lines and gradual turns. And sensor choice, we can use infrared sensors. That's a pretty good thing. Now notice, I don't really know a lot about this domain. I know about the code piece of it, but I don't know about the other one, and I'm just engaging it in a conversation to get something out of it that I want. Remember, I want to build a robot, I want to be able to 3D print parts, I want to be able to assemble circuits for it, and I want to be able to run code on it. So then I say, well, what do we do next? Just tell me the very next steps and nothing else. And it says the next step is brainstem concepts, and it says we can use 3D models of the robot. Now, it sounds like I've reached a dead end, right? Like, how am I going to do 3D models with it? And so I just ask it, how do we do this via chat? Because I'm trying to refine what's going on here. I don't want to just assume I'm stuck. I can't get out. I want to keep refining and moving the conversation to try to get to my goal. And it says, since we are communicating through a text-based chat, we can use shared documents or diagrams to collaborate. We can use Google Drive or Dropbox. And then it mentions different tools like Sketchpad or Microsoft Whiteboard. And I just realized, like, you know, that seems tricky. I don't know how to get around that. And then I realized, oh, you know what? I have some knowledge of the domain. I know that 3D printers use G-code. This is something that the instructions are sent to them. So I just say, can you show me sample G-code that I could give a 3D printer to print 4 wheels for a robot? And so I'm trying to steer around this roadblock. And then it says, yes. And so it goes and gives me some G-code, which I look at, and I have enough domain knowledge from this to think that I'm kind of skeptical that this is real G-code, and I don't really even see some wheels. So then I go, can you explain where the wheel shape is created in this G-code, right? So I've kind of gone down to a rabbit hole now where I seem to be hitting roadblock after roadblock, but I'm continuing the conversation. I'm still problem solving and thinking about how do I get around this. And it says, I apologize for the confusion, but the example G-code I provided earlier is just a sample start and does not have any instructions for creating the shape of the wheels. Now, I then say, could you create sample Python code that I can run to create an STL file that has 4-inch tall wheels with a 0.1-inch hole in the middle for an axle? So what I'm doing here is I'm trying to come up with additional tasks that it could do that would help me solve my problem. Now, the way that I worded it, the way I saw it out, solving the problem the first time didn't work. And I keep hitting roadblocks. So what I'm doing is I'm retrying with a different task that would be useful to me to solve my problem. So I'm kind of thinking about this as almost like a tree. Like I've reached a critical point and I've tried to go in one direction, but it's told me it can't do it that way, or it's giving me an erroneous output. So now I'm trying a slightly different tact to go and solve my problem that'll still help me get there. And this one is one that it is able to do. And STL files are basically files that you can use to describe the geometry of some 3D shape, and then basically give them to specialized software, which can then send them to a 3D printer to be printed into a shape. So this one, it actually is able to go and create what looks like STL code, and I didn't actually try to print it. I'll be fully honest. I'm just wanting to illustrate the conversational aspect of this. But it certainly has things that look like wheels in the output that it's producing. It's looking like it produces something that's probably going to give me something that I could 3D print. And then I say, well, I'd like to pick electronics for my robot. Can you tell me what components I need and how to wire them together? and it starts giving me information. I need a microcontroller board, I need a motor driver board, infrared line sensors. And surprisingly, it actually tries to generate an image, which is obviously not possible in it at this point with what I'm using, but it still tries to do it. But it gets the image and it's broken again. And so I have to think about, how do I get around this problem that it can't generate image? Because I'd like to help it pick electronics for me and show me how to wire them together with a diagram. So what I do at this point is I say, well, I know there's this other tool that uses text as its input. It's called GraphViz. And so I ask it to create an input for that tool that can visualize the diagram, the circuit diagram for this tool, or at least do a rough approximation of it. And then it can do it, and it generates for me a circuit diagram for the robot. And I continued this conversation for a very, very long time, trying to iterate and improve the definition in the circuit diagram, picking different components, generating source code to run on the robot. It had picked an Arduino component and then had generated code to run on the Arduino. And then I even took it to the point where I went all the way down and I said, hey, we've covered a lot of concepts. Now, this is one of the things that's really powerful about the conversation, is you can take the conversation in a lot of directions. And as you realize you'd like additional things, you can ask for them. So in this case, I said, hey, summarize the main topics that we've covered. And it was able to do that. Gives me a summary of all the main topics. And then I did something interesting. I said, well, let's take it even further. So I've learned a lot by going through this design process. Now, I haven't actually gotten something that I could probably build a robot yet with. If I interacted more, I probably could, but I actually asked it to quiz me from the electronics questions, and it's able to do that. And so what you can see here is a lot of the power of these large language models comes from not just thinking of them as a one-off. Like, I ask it a question, it gives me a response. Or I asked it a question, it gave me a response that wasn't very good, or it couldn't answer it. We should always be thinking about, how do we take the response and use it to inform a next question for the conversation, or a next statement for the conversation? Or how do we give it feedback on what it did well or what it didn't do well? That's how we get the really useful products. That's how we go from thinking of it as a hammer where we strike once, it doesn't give us what we want, and we throw it on the floor. That mindset is wrong. We want to go to the mindset of, it's a hammer, we're going to have to chisel away at the rock to get the really beautiful outputs of it. And so if we're not continuing the conversation, continually asking follow-up questions, problem solving in the conversation, trying to move around roadblocks, taking what we're being given and giving it different shapes and formats that may be useful to us, we're really missing the underlying sort of power and capabilities of these large language models.